Welcome back to another video, and in this video we are talking about exponential functions, logarithmic functions, trigonometric functions, and inverse trig functions. So now, during our previous video we mainly talked about the basics of derivative rules, like the constant rule, the sum and difference rule, and just the power rule just in general. And also we tried to prove some of those. But this time, we're going to be talking about more of the more complex functions, as I used to call it. For example, like e to the x power or any number to the x power, right? So let's start with exponential functions here. Exponential functions. Now, some examples of these functions would be like, let's see, e to the x power, or 5 to the x power, or 5 times 6 to the x power, right? Those are just a few examples of what we call exponential functions. It's because on the graph, they're moving up exponentially, hence why the name of exponential function. Now, you might ask, oh, what is the derivative of e to the x, right? So now, the derivative of e to the x is just e to the x. And then now, since you guys know what the derivative of e to the x, do not get it mixed up with any other value that we have here. So the derivative of 5 to the x would be different from e to the x. So now, let's state that we have a constant inside, like as the main factor, right? So it would be like n to the x power, right? N equals any number. Now, the derivative of n to the x will just be n to the x, but you have to times it by ln of n. So it's not too bad, right? So, as a few examples, if we had d over dx, the derivative of 5 to the x, right? That's just going to be equal to 5 to the x times ln of 5, right? Because you're maintaining the original function, but then you're also adding onto the ln of whatever number you have. So the 5 here in this case. Alright, so next, let's try a example on your own by using these rules that we have here. Let's say you have to find the derivative of 5 to the e of x minus 3 to the x power. Take a moment here and pause the video and see if you can figure this out. Hopefully you just pause the video and try to figure this out. So now let's try to use the rules here. So since we know that for our first term our first term is 5 to the e of x, and then our second term is 3 to the x. We can use this difference rule, right? So we're just going to take the derivative of each of the individual terms. Minus d over dx of 3 to the x power. So now we're taking a look at this, right? And we see that 5 in the first term is just a coefficient. So we can bring that outside in this case, right? So now the derivative of e to the x is just e to the x. So our first term stays the same as 5 e to the x. Now our second term here, the second term that we have is a little bit different, right? It has a number, but then x is as exponent, right? So now we keep it the same, but then we multiply it to ln of the base. So ln of 3. And that is our answer. Right? So as a recap, exponential functions, you can solve for the derivative of them just by these two different rules here. Remember that e to the x is not the same as any number to the x power. So you have to have a separate rule for that. Now our next topic here is logarithmic functions. So let's write that down. Logarithmic functions. So now a few examples of these, right, would just be ln of x or log base 5 of x, right? Now, since these are examples, right, we can use this similar structure here. So the derivative of ln of x is just equal to 1 over x, right? Now, the derivative of, let's say, log base a of x, right, equals 1 over x ln of a, right? So make sure that, you guys don't forget that it's different with these two functions, even though they might look the same, right? So as an example that we might have is like, oh, find the derivative of ln of x, well, 5 times ln of x, right? Now 5 is the coefficient here, so we place it on the outside, so that would just be 5 times 1 over x. That's simple. Now let's say it was find the derivative of log 5 of x, right? Then that'll just be equal to 1 over x. Remember, x stays the same, but then you take the ln of the base, which is ln of 5. Now take a look at this example for yourself and see if you can solve it. So find the derivative of 5 ln. Actually, let's make it 6 ln of x plus log 6 of x. Try solving this out. hopefully you just pause the video there and try to solve it for yourself. Now let's get right into it. So we can see that they're separated by a addition symbol, so we can use the addition the sum rule, right? So we have two terms here, right? So we're going to take the derivative of each of these integer terms. So the derivative of 6 ln x plus the derivative of log 6x, right? Alright, so now, since we know that 6 is a coefficient, we can always bring it onto outside because of the coefficient rule, right? And now, this would equal to, just by taking the individual terms, 6 over x plus the 1 over x ln of 6. And that is our answer. Alright, so this is where it gets a little bit confusing because now we're entering trigonometric functions, including its inverse, right? Now we have a total of 6 trig functions that we usually use. And let's write this down. Trigonometric functions. Right. So now we have 6 of them. D over dx of sine x, right, equals what? D over dx of cosine x. D over dx of tangent x. We have the derivative of cotangent x. And then the last two ones are just secant x. And last one is cosecant x. Alright, so now, since we have all of these 6 different trig functions, the last two are a little bit more complicating. Well, the last 3 is more complicating. But the first 3 is served as like a basis because the first 3 appears the most common, I would say, out of like all the AP tests and stuff like that. But you still gotta memorize all of them just to be prepared for it. Alright, so the derivative of sine x is just cosine x. The derivative of cosine x is just negative sine x. Now, you see a little pattern there, right? Where it's just the reverse, the opposite signs, right? Now, the derivative of tangent x is secant squared x. And the derivative of cotangent x is just negative cosecant squared x. Now, you also see this pattern here where the co of the original trig function is a negative, right? So now, if the derivative of secant x is just secant x times tangent x. But on this side, where we have cosecant x, it's going to be negative cosecant x times cotangent x. Right, so those are our different functions that we have here. So as an example to show, right, as an example, we can use sine x plus cosine x, right? Find the derivative of that. Now, since they're both separate terms, we can just solve it right off the bat. So the derivative of sine x is cosine x, and the derivative of cosine x is just negative sine x, so just minus sine x. And that's your answer right there. Alright, let's give you another practice problem here. So the derivative of, let's see, tangent x plus a secant x. Try solving this. Take a moment for yourself. Or hopefully you just pause the video and try to figure it out yourself. Since they're both separate terms, we can just take the derivative of each. And that will lead us to the derivative of tangent x is just secant squared x. And then the derivative of secant x is just secant x times tangent x. And that is your answer right there. Now, you might ask, what if it was inverse trig functions, right? Because those act a little bit differently here. So inverse trig functions. Now, of course, we're gonna have the same trig function that we just had, but just the inverse of them. So now there's two ways of writing the inverse of these functions. One's by using the notation where there's the -1 as an exponent, but then the other way is just using arc. It's like arc sine, arc cosine, arc tangent, right? So those are the two ways. I'm gonna write both of them just so that we're all clear on them. So for the first one, let's do the derivative of arc sine x or sine -1 x. And that's just equal to 1 over the square root of 1 minus x squared. Alright? Now, for our second one, we're going to do the inverse of cosine x. So the derivative of arc cosine x or cosine -1 of x. Now, as we've seen in the previous problem where it has the negative, it also applies here. So this will just equal to -1 over the square root of 1 minus x squared. Now, third, we're going to have tangent x. So arctan of x or inverse tangent of x equals to 1 over 1 plus x squared. Then we have arc cotangent x, or just inverse cotangent x here. And that, you can tell it's equal to -1 over 1 plus x squared. And for the last two, which we probably never gonna use ever, it's just arc secant x or secant to -1 of x, right? And that's just equal to 1 over, this one's a little bit more complicated here, the absolute value of x times the square root of x squared minus 1. And of course, last but not least, of arc cosecant x, or cosecant -1 of x, equals 1, well, the negative of 1 over absolute value of x times the square root of x squared minus 1. There you go. So now these are different trig functions for inverse, and we barely use them, but I think once in a while you're gonna see one approach you. So it's good to keep it in the back of your mind. So now, next video we're going to talk about more of the product rule, quotient rule, and chain rule, just so that we can finish off derivatives. And once you guys understand all of these rules, you guys can put them together, do whatever you need to solve the derivative that is like really complex. So make sure that you guys keep on practicing, and I will see you guys in the next video.